Finally, the last shape that we're finding the volume of is a sphere. And once again, your textbook goes through on pages 963 and 964 an explanation that I think is a little bit more confusing than it is really worth to give us this formula that we have here for the volume of a sphere. So we have all this information in the problem, and let's cut to the chase and look at the question. How much helium to the nearest 100 gallons does the balloon hold? Well, in order to figure that out, I need to find the volume of this sphere. So step one, we are finding the radius of the balloon, which they found here. And so 4/3 times pi times 36 cubed. In our calculator, we evaluate that. So we take 36 to the third power times pi times 4/3. And we get 195,432 cubic feet. Next, we find the capacity of the balloon to the nearest gallon. So we have this conversion factor here for what a gallon is equivalent to in cubic feet. So my volume was, once again, 195,432 cubic feet, which I'm going to then multiply by 1/1.337 to convert it into gallons. So that means I'm dividing by 0.1337. And that is 1,461,722 approximately gallons. And it says to the nearest 100 gallons, so 1,461,700 gallons. Here we have a spherical water tank, and I'm asked how much water does it hold if I know 1,000 liters is equivalent to 1 cubic meter. So again, the formula is 4/3 pi r cubed. I know my diameter is 27, so my radius is 13.5. So 4/3 times pi times 13.5 cubed. So 13.5 cubed times pi times 4/3 is 306. Find the capacity of the tank to the nearest liter. Okay, so this is cubic meters. And since 1,000 liters is equivalent to 1 cubic meter, I'm going to take this 10,306 cubic meters, maybe I want to put that over 1, and multiply it by 1,000 liters, 1,000 liters per cubic meter. So that is 10,305,994 liters. Once again, a composite figure. So what I have here is a hemisphere on top of a cone. So find the volume of the hemisphere by taking, well, let's think about it. A sphere is 4/3 pi r cubed. So if I'm dealing with a hemisphere, that's half of that. So that'll be 2/3 times pi r, which is given to us as 5 cubed. So that is 5 to the 3rd power times pi times 2/3 is approximately 261.8. Notice again, they gave us the wrong height, so we have to use Pythagorean's theorem in order to find it. So h squared plus 5 squared equals 13 squared. H squared plus 25 equals 169. So h squared is 144, and that's why h is 12 when I take the square root of both sides. So the cone has the same radius as the hemisphere, so my radius is 5. So that'll be 1/3 times pi times 5 squared times my height, which we just found to be 12. And when I type that into my calculator, I have 5 squared times 12 times pi times 1/3 is 314.2. And when I find the total volume, that's 261.8 plus 314.2, and that is approximately 576. Is it possible to create a figure by taking a cone and removing it from a hemisphere with the same radius? Well, forgive my drawing skills, but let's consider a hemisphere and a cone removed from it. Sure, it's possible. So, yes, the height of the cone must equal no more than the radius of the hemisphere. Hemisphere. Finally, we have a composite figure made up of a hemispherical hole in a cylinder. So the bottom of the hemisphere is tangent to the base of the cylinder, which tells us that since this diameter is 7, this radius then is 3.5, which means the height of the cylinder is also 3.5. Okay, so the volume of the cylinder would be pi r squared h, remember is our formula, so pi times 3.5 squared times 3.5. Which is 134.7 approximately. Now I'm going to find the volume, of the hemisphere. Remember how back here I told you that since a sphere is 4/3, then a hemisphere is 2/3 pi r cubed. So the volume of the hemisphere is 2/3 pi r cubed, so that's 2/3 pi times 3.5 cubed. cubed, which is 89.8. So then the volume of the composite will be 134.7 minus 89.8, giving us approximately 44.9 cubic inches.